was Galileo. Galileo was the first person to use a telescope, actually, to view the heavens. He did not invent a telescope. I've read where he did not. He just used it. But he was the first one to see the impact craters on the moon very clearly. He was the one to see the circles, rings around Saturn, although now we know they all have rings. But he was the one also that observed Mars. And what he saw on Mars were these grooves on the Martian surface, and he made note of that in his notebooks, but apparently he didn't really take it much further than that. But later on, there were two Italian astronomers independently studying Mars, and they saw these grooves on Mars. Matter of fact, they even made maps of them, and they published their work in Italian, of course. And in the Italian, they reported the presence of these grooves, and they reported in Italian that the Martian surface was cut by canali, which is in Italian, channel. Well, when they were translated into English, whoever did the translation screwed up. Because what they did, they translated the canali not as channel, but as canal, which it really did look like, I guess. Well, there's a big, big difference between a channel and a canal. Channels are natural features. Channels are carved by streams, for example. Every stream has a stream channel. Glaciers carve channels. Even the wind, in some cases, can carve a thing that looks like a channel. So these are natural things. A canal, on the other hand, is a ditch dug by somebody to move water from one place to another. As soon as the general population saw that, here was the proof. There are people up there. There are Martians. They really do exist. And it wasn't just the average person. Percival Lowell, who was one of the leading astronomers of the day, spent a lifetime and a fortune trying to prove it. Question: are there canals on Mars? No, there are no canals on Mars. Are there channels on Mars? Yes, there are channels on Mars. And that's what geologists are so interested in. There are channels on Mars. There is absolutely no doubt in any of our minds that the channels we see on Mars were carved by streams. These are stream channels. There are deposits that are stream deposits. There are deposits. Every indication is that the Martian surface once had water on it. It was not quite as much as we have. In other words, 70% of Earth is covered with water, the oceans. I don't think the Mars had that sort of water. Maybe they had huge, huge lakes, but nevertheless, water existed. What does that mean? That means they had to have an atmosphere like ours that was dense enough to keep the water from evaporating. They had to have an environment that would support life as we know it. That's the important thing about all that on Mars. That's why people are so interested in getting to Mars, is trying to find out what's going on or what did go on. Because now there is no water on Mars. Oh, there may be some water underneath the frozen ice caps of the polar regions, but they're not ice now. The water ice, that's frozen carbon dioxide. Some people think there may be some frozen water ice deep within the soil. Maybe, maybe not. But the point is, the atmosphere disappeared. Once the atmosphere disappeared, it's like a vacuum. All the water disappeared too. Question: what happened? Answer: we don't know. And that's what's so interesting about Mars, is what happened to Mars. Because here we are, just right next door. What happened to Mars? Could it have happened to Earth? Possible. We don't know what happened anyway. So anyway, there's the 4 planets. Now these are grouped together now, and they're referred to as the terrestrial planets. Because these 4 planets, Mercury, Venus, Earth, and Mars, all have things in common. First of all, they're all relatively small. Venus and Earth are about the same size, 8,000 miles in diameter. I think Mars is about 4,000, and I think Mercury is about 3,000 miles. But anyway, they're all small. Dense, the average density is about 6. So we group them together and call them the terrestrials. They're all made of the same stuff, so the things we're going to talk about, Earth being made of, they're made of the same stuff. Now, the outer planets would be Jupiter, Saturn, Uranus, and Neptune. These are the great, great gassy planets. These are the planets made of frozen gases or gases in one form or another. Now, these are huge planets. Jupiter, for example, is 90,000 miles in diameter. 90,000 miles. You could take all the other planets, roll them into one ball, and the ball wouldn't be as big as Jupiter. It's humongous. So these are very, very large planets. Being made of gas, of course, They're nothing like Earth, and I really don't know much about them other than that they don't really contribute much to our understanding, so we'll sort of leave the Jovian planets, although are the Jovian planets, that's what classified as the Jovians. Now, in between Mars and Jupiter is where the asteroids are, or most of them, I guess. What are the asteroids? Well, they're just bits and pieces of rock from what we can tell. They're just odd-shaped things, so they're not big enough to become spheres. I think the large one is something like 700 miles in long dimension, and even at that, that's not large enough to have the mass to be molded into a sphere. So these are just simply odd-shaped bits and pieces of rock. The question is, what are they? Well, when I took my first geology course, and I was taught that what they were the remains of a terrestrial-type planet that was in the orbital between Mars and Jupiter that disintegrated. How? Nobody knows. Was it hit by something and just split apart? Possibly. Who knows what happened to it? But it disintegrated, which means what the asteroids are the bits and pieces of that once existing terrestrial-type planet. I don't think that's what they consider now. I think today what they consider these to be are planetesimals. These are planetesimals that were going to get together to form another terrestrial planet, but never had the opportunity. Why? Well, first of all, you had this humongous planet, Jupiter, right on one side, pulling them in that direction. On the other side, you had the sun and everybody else pulling them in that direction, and this tug of war between those two forces of gravity simply prevented them from getting together. So I think what they think the asteroids are now, they are simply planetesimals that would have gotten together had they had a chance, but never had the chance. Let's see now, the next one, meteoroids. Meteoroids, well, here's the first thing. There are three words, meteor, meteoroid, and meteorite. I always ask students, what's the difference between them? Question, what's a meteor? Well, a meteor is really nothing. It's just a flash of light through the sky. And what it is, it's either a meteoroid or a meteorite burning up as it plunges into our atmosphere. And then the question, of course, to be asked is which one of those is it? Well, it turns out as long as they stay up there, they're oids. Once they land on Earth, they're ites. So that's the difference between them. It's just location. Now, kinds. There are three basic kinds of meteoroids. There are the stonies, made of just, as it says, rock. There are the ironies, made of iron. And then there's the stony ironies, which are mixtures. Now, of the three, apparently the stone ones are by far the more abundant, most abundant. How do we know that? Collections made in Antarctica. Down there, you see they all fall into the ice, and then at the front of the ice, where the ice is melting away or sloughing off, they just go around and pick them up and just count them. It's just that simple. So anyway, the stonies seem to be the most abundant of all. We always want to question about impacts. Well, an interesting question that was asked to me one time was, why is it that you look at the moon, and here on the moon, only 238,000 miles away, all the impacts you see there are probably from meteoroids impacting the surface of the moon. Most of those are very, very, very old. We're dating back now to the primeval days when the planets were first being created, possibly even in that transition into the planetary stage. So they're very, very, very old. There are very few new ones. Well, the question was, why do we have all those on the moon, and here we are only 238,000 miles away, and you don't have any on Earth, or very, very few? Well, the answer is, back in those primeval days, we had the same number of impacts that they had. Now, the difference, well, the difference is, first of all, we have 70% of the area covered by water, so most of the things that fell in the ocean where you'd never see them anyway. But what about the land? Why don't you see craters on the land? Well, the reason why is one of the topics we're going to take up later on is weathering. Weathering and erosion. Those two things combined, they're like big erasers. And they simply erase things, like mountains are erased by weathering and erosion, let alone craters. But the interesting thing is, now that we're up above Earth and satellites, looking down, we're starting to see faint outlines of old impact craters. It's like, for example, if you took a piece of paper and drew a circle on it with a pencil and then tried to erase it. Is it absolutely gone? No, you can still see the image of that circle. So the same thing is true here. There are images out there that we're now starting to see, and there are a lot more than we ever suspected before. The most recent one, the most recent impact of a meteoroid becoming a meteorite is, of course, Meteor Crater, or the Barringer Crater is the true name of the place down in Arizona. Here you have a hole in the ground. It's about a mile across, about 500 or 600 miles deep. This thing was estimated to have been caused by an iron meteor, or stony meteorite coming in, probably weighing about 250,000 tons, traveling at 25,000 miles an hour when it hit. And I always ask my students, remember now, this is about 50,000 years ago. 50,000 years ago, there were no human beings in the Western Hemisphere yet. So my question to my students are always, did it make a sound? And that's just sort of a philosophical thing you might think about yourself. Okay, so they have those. Now, the comets. The comets are, well, before we get to the comets, let's go back to one more of our planets. I want to take a little bit about Pluto. Pluto is the maverick planet. It doesn't fit anywhere in the picture. If it fitted into the picture, you see, it should be one of those large gassy outer planets, and it is not. It's small. It seems to be made of rock. We really don't know what it's made of because it's so far out there. All of our pictures are even very, very fuzzy. It was only discovered in 1933. Mathematically, as a matter of fact, it was located. But anyway, we don't really know much about it. Probably what it was, maybe a captured something from outer space, just came in at the right angle, caught by the gravitational pull of the sun, went into orbit around the sun. And nothing fits. The orbital isn't in the ecliptic where all the other planets orbit the sun. It's about 17 degrees to it. It has a huge elliptical orbit where all the others are almost, not exactly, but almost circles. Copernicus told us they were not circles. But anyway, it's so much different that today, recently, I read again where they're trying to downgrade it. They're trying to downgrade it from a planet to something else. I think the problem, however, is that it's been a planet for so long that I don't think they're going to do it. At least, well, stay tuned. We'll see if they eventually do downgrade it from a planetary status. Now to the comets. The comets are sort of strange, too. There aren't very many of them, well, named ones. There are about 100 or so named ones. And what they are, they were described by Whipple as being dirty snowballs. And I think that's a great description, a dirty snowball, because what he thought they were simply balls of frozen water ice. And the dirty part would be bits and pieces of rocks and stuff inside that dirty snowball. Now, if you think about that, that basically is the composition of the stuff out there at the outer edge of that disk when we talked about separating the ices from the heavy things. So these seem to have, maybe there's something to do with those outermost planets that form way out there. Well, anyway, we really don't know, but that's the interesting thing about the comets. The other interesting thing about them, there seem to be two sources of them. One is called the Oort cloud. The Oort cloud was postulated by a Belgian astronomer by the name of Oort. He said out beyond our most distant planet, possibly halfway to the nearest star, which is, the star is 4.4 light years away, so this may be 2 light years out there, you have a belt of these things going around the sun. There are comets that apparently come off that and in around the sun, but you never see them again because the orbital period is so great. We think now that the ones we see are actually orbiting around the sun just beyond our own solar system, known solar system. They come in around the sun, and again, these huge elliptical orbits. And the interesting thing about them are their tails. People think the tails trail behind them. No, they don't really. The tail of a comet is generated as a result of that solar wind impacting the front face of that frozen ball of ices, vaporizing, ionizing them, driving them away from the sun, and then when the electrons go back, of course, they make it into light. So as the things go around the sun, through our solar system, that tail constantly swings around, eventually always pointing away from the sun, and when they're beyond the orbital of about Jupiter, the tail goes out. So it's only when they're in closer than about the orbital of Jupiter we actually have them. Impacts of comets. Pretty rare, pretty rare. The two I might comment on, at least we think both of these were, there was one that we think crashed into what is now the Gulf of Mexico about 60 million years ago, and that's the one that is reputed to have given the death to all the dinosaurs at the end of the Cretaceous period. That's still up for argument whether it really did or not. But that was about, it's been known now, it did indeed crash there. Whether it gave the demise of the dinosaurs is still up for argument. The other one came down over what is now Siberia, I believe it was in 1912, and we're almost certain that it was a comet because it took about 20 years to get in or see the place. But when they got there was no hole, so it didn't impact the Earth. There were no bits and pieces of rock or metal anywhere around, and it wouldn't be, of course, if it was just frozen gases. And so that's what we think it was, an impacting comet. But other than that, the possibilities of being hit by a comet, pretty rare. You can probably get comet insurance really, really, really cheaply. So anyway, there's your solar system, and the next thing we want to go on is to what has to be the most significant concept ever set forth in the whole history of geology, namely plate tectonics. Stay tuned.